Hello everybody and welcome back to another math video. I'm Mr. Schmidt and today we're going to be talking about one-step equations and solving them using algebra tiles. This is a skill I really like to teach, but I also like to work through it with my students as well because we get to take something that's very mathy and break it down and physically solve the problems with our hands. So we're going to be working on problems like the ones you see on the left. Each one of these is a specific equation, and we'll talk about what that means in a little bit. And our goal is not only to get the answers, but it's to be able to represent them with algebra tiles and showcase that we understand the procedure. Let's get started. For those of you who have been in my class for a while, you know that I care really deeply about making sure that the math we're learning in class is math that you can actually use in the real world. And equations are something that you already do each and every day, but you don't realize it. So the questions are, what is an equation and why do I care? Well, an equation is just any mathematical representation where two values are equal, okay? And the most important part here is the R equals. So in order for you to have an equation, you need an equal sign. If you don't have an equal sign, you're doing what we call an expression. And many times people treat those as if they're the same, but for our problems, you need an equal sign in order to solve it. The other really important part of an equation is a variable. A variable is a mathematical symbol, usually a letter, that can represent any number. Okay, so if I have the letter x or the variable x, this can represent any number in the course of my problem. The reason why these are called variables is the word variable outside of a math classroom frequently means to change. Something that is variable means that it has the ability to change, which is why these letters can be any number. Now, when we look at equations like the ones we have here on the right, these are the same ones from the beginning part, we can solve these simply by using some critical thinking and problem solving. Instead of the letter X, if I just think of this as a box and say something plus 3 has to equal 8, I'm hoping that many of you figured out right away that this should be 5 plus 3 equals 8, which means our variable x equals 5. For the problem below, 3 times something has to equal 12. And I'm hoping that many of you realize that 3 times 4 has to equal 12, which means our variable y has to be equal to 4. The problem down here on the bottom, I think, is definitely the most difficult of these ones, because you got to be very careful with those negatives. But I believe many of you would understand that negative 3 plus 9 is equal to positive 6, meaning our variable b is equal to 9. And many of you have probably seen something like this before, and you might be watching this video thinking, well, I'm not going to be learning anything new here. But I want each and every one of you to think about what real-world application would I be solving with those equations? Well, for the problem at the top, if I'm doing something plus 3 equals 8, maybe I'm thinking about, the temperature outside and that it is currently 5 degrees. And if I increase it by 3 degrees, it's 8. Sure, you're not going to write down the equation, but you're still using that critical thinking. The second problem, maybe you have 12 candy bars and you have 3 friends and you want to split them evenly between those 3 friends. Sure, you're not going to write out the equation, but you're still using that equation problem solving. And that's what I want you to get out of this video, is that problem solving. To help us solve equations, we're going to use something called algebra tiles. And if you have done integers with me, you've seen these top parts here. We called those plus minus chips, and that's half of algebra tiles, a red positive chip and a blue negative chip, and they can be any color. And then we just use these tiles to represent numbers. So a positive x can represent any number, and then a negative 1x would represent the same number, but negative, or opposite if the number was negative to begin with. So as a review of plus minus chips, if I have these many positive chips and this many negative chips, I need to create zeros because I know that +1 and -1 create a 0 and can be ignored from our board. We can create another 0 here and can be ignored from our board as well, meaning that in our case, we would have a value of -1 here. Okay? So let's look at what that means for an equation. So we're back at that first equation that we worked with on problem 1, which we know the answer should be 5. And we want to now create an algebra tiles equation to represent it. So I have a +1x here on the left. I'm going to put that here. And I have 3 positive chips that I want to put here on the left as well. So 3 positive chips right there. Now the equal sign, we want to create a separator. So usually on my table, I use a ruler and I separate the center of my equation to make sure I have it perfectly understood. And now I need to create 8 positive chips on the right. And I'm not sure if I counted correctly, but we're going to certainly hope so. And look at that. Okay, so there are a couple different ways to solve this problem. Okay, the first one is to think of a number of positive chips here to make both sides of our equation equal to each other. In that case, I could change this value into 5 of these values, and then we have 8 on both sides. So that's one of the ways, is simply change the variable into some numbers. The other way, and the one that I actually prefer, is I think about, I want to get the x alone. The x is a little bit like Mr. Schmidt during lunchtime. He just wants to be left alone. So I have to think about what is the opposite of the values that are on the same side as the x. Well, the opposite of +3 is -3. But a huge rule in equations is we need to keep the sides of our equation equivalent or equal. So if I added -3 to one side, I would have to add -3 to the other side. And from here, all I have to do is simplify. This creates a 0 and can be ignored. This creates a 0 and can be ignored. And this creates a 0. So on the left side of the equation, I only have 1x left. And on the right side of the equation, I create a 0, I create a 0, and I create a 0, and I have 1, 2, 3, 4, +5 left, which is what we had through the critical thinking. We're going to do lots more examples on this, but there are 2 different ways that we could solve this equation, but what I care the most about is, can you represent the equation with the algebra tiles? Let's do 2 more examples on representing equations with algebra tiles, and then we will move to the retake video. So the first thing I like to do with any equation is draw the line down the equal sign to separate both sides of the equation, reminding myself they have to be equal on the left and the right. On the left side of my equation, I have 3 y's. And one of the important parts of a variable is the variable can be any letter that represents it. So if I take a x algebra tile, that is the same as using a y algebra tile. They are equivalent to each other. And on the right side, I have +12. So should have picked smaller numbers. So, and my goal here in this problem is to figure out, what does each variable represent? So the best way to solve this problem, I believe, is to think about each x as a separate category, splitting them up evenly like this. I have 3 separate x's. And then I'm going to put my values split evenly between them. And since these are all positive, I can organize them however I want. But at the end of the process, I see that each individual x, or in our case y, is equal to positive 4. Now, some students will look at this problem and think, well, you just have to divide both sides by 3. But dividing by 3 mathematically means that you are making 3 equivalent groups. Okay, so this is what dividing by 3 looks like with algebra tiles. Let's do one more. I have negative 3 plus a positive variable b, and that's equal to positive 6. So move these over here. I'm going to add 3 negative chips to the left side. And I'm going to add a positive variable to the left side. Whoops, there we go. And on the right side, I need 6 positive chips. Okay, so I'm getting better at this process. Takes practice. Okay. Now, we talked about this on the first one. There are a couple of different ways to solve this, but I believe the easiest way is to think about it like Mr. Schmidt at lunchtime. He just wants to be left alone, so we got to get rid of the thing that's on the same side as him. So in this problem, the thing that's on the same side are 3 negative chips, and the opposite of 3 negative chips would be 3 positive chips, and I can add that to both sides. But it's very important to remember to add it to both sides because we have to keep our equation equal. And if I only add it to one side, I do not have an equal equation anymore. And I have a 0, a 0, and a 0. Okay? Many students who are a little bit neater than I am would simply erase it. Now I have a single variable left alone, and on the right side I have positive 9, which means our answer would be b, or 1b, is equal to positive 9. Now remember, as you start solving these problems, it's not just about getting the answer, it's about showing that you understand the process. So the algebra tiles part might be new to you, but it's something that we need to do to make sure we understand how to solve these as we get into harder and more difficult equations. As always, if you have any questions, please let me know.